Good day, class. Today we'll learn about whole numbers, numbers we use every day when we count, add, or measure things. We'll explore how to read, write, compare, and round them, and how to perform the 4 basic operations. Let's begin. Whole numbers are the counting numbers starting from 0. They have no parts or decimals. We use them when counting people, books, or apples, anything we can count exactly. Each digit in a number has a place value, depending on where it is. From right to left, we have ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions. In 6,582,349, the digit 6 means 6 million, while 9 means 9 ones. Each place multiplies the digit by a power of 10. We read numbers in groups of 3 digits called periods. For example, 325,487 is read as 325,487. When writing numbers in words, remember, use commas for separation but no and unless indicating decimals. Write clearly to show each period's value. Converting from words to symbols helps practice understanding place value. Always check zeros carefully. Missing one can change the number completely. Try reading and writing these numbers yourself. Always group digits in threes to make reading easier. For the first part, 1. It is 412,508. 2. 9,006,001. For the second part, 1. 4, 5, 0, 0, 0, 6. 2. 2, 3, 4, 5, 0, 1, 0. To compare numbers, start from the leftmost digits. The number with the larger digit in the highest place value is greater. This table shows how comparing digits in the same place value helps decide which number is greater. In the first row, 56,821 greater than 56,729 because of the hundreds place. We compare digits from left to right or from the highest value digit going to the lowest value digit. Just like what we did in second example also. In ordering numbers, we look at the highest place value digit, then we rank them according to the given condition. In the example given, we arranged it from least to greatest. 732,998 is the lowest and 748,000 is the greatest. A bar chart can visually show which numbers are smaller or greater. Helpful in ordering and comparing numbers. Rounding makes numbers simpler and easier to work with, especially when exact values are not needed. To round a number, look at the digit to the right of the place value you're rounding to. If it's 5 or more, round up. If less than 5, round down. Here, 368 becomes 370 when rounded to tens. For hundreds, look at the tens digit. For thousands, look at the hundreds digit. A number line helps learners see which number a value is closer to, very useful for understanding rounding. In addition, line up digits by place value. Start from the ones place and carry over to the next place value if the sum exceeds 9. Like in this example, 35,416 plus 4,523 equals to 39,939. We first line up them according to their place value like 6 and 3, then add them starting from ones. 6 plus 3 equals 9. 1 plus 2 equals 3. 4 plus 5 equals 9. 5 plus 4 equals 9. Lastly, 3 plus 0 equals 3. The final answer is 39,939. Add column by column, carrying over as needed. Check each place value to ensure proper alignment. Start from ones. 1 plus 4 plus 2 is equal to 7. 3 plus 8 will give us 11, so we have to put 1, then the other one will carry over to the next place value. 1 plus 2 plus 1 plus 5 is 9. 5 plus 3 plus 6 will give us 14, put down 4, then carry over 1. Then for the last 1 plus 4 plus 2 will give us 7. Resulting to the answer of 74,917. Moving on to subtraction. Let's subtract 2,468 from 7,305. We start at the ones place, just like in addition and subtraction. We look at the ones place, 5 minus 8. We can't subtract 8 from 5 because 5 is smaller than 8. So we need to borrow 110 from the tens place. The tens place is 0, so we can't borrow directly from there. What do? We move one place to the left, to the hundreds place. The hundreds place has a 3. We borrow 100 from it. When we take away 100, the 3 becomes 2. The tens place, which was 0, now gets 10 tens. Now that the tens place has 10, we can borrow from it. We take 1 10, that's 10 ones, and give it to the ones place. The tens place goes from 10 to 9, and the ones place goes from 5 to 15. Now we can subtract 15 minus 8 equals 7, 9 minus 6 equals 3. We can't do 2 minus 4. We'll need to borrow from the thousands place. The thousands place has a 7. We borrow 1000, so the 7 becomes 6. The hundreds place gets 10 more hundreds, so 2 becomes 12. 12 minus 4 equals 8. 6 minus 2 equals 4. Final answer, 4837. In this example, same rules apply. When borrowing across zeros, remember to move left until you find a non-zero digit to borrow from. Moving forward to multiplication. Given this example, we multiply 245 by 23. There are two methods to solve this example. The first method is called the area model. A helpful way is to break 23 into 20 plus 3 and multiply 245 by each part, then add the two results. We can also draw split box columns for 200, 40, and 5 and rows for 20 and 3. Then we multiply each pair and add the two results, which is 735 and 4900, which will give us 5635. The second method is called the standard column algorithm or the long multiplication. Write 245 on top and 23 under it. We multiply by the ones digit first, which is 3, then by the tens digit, which is 2, but remember it represents 20, and then add the partial results. 3 times 5 equals 15, write 5 in the ones column, carry 1 to the tens. 3 times 4 equals 12, plus carry 1, 12 plus 1 equals 13, write 3 in the tens column, carry 1 to the hundreds. 3 times 2 equals 6, plus carry 1, 6 plus 1 equals 7, write 7 in the hundreds column. So the first partial product, 245 times 3, is 735. Multiply by the tens digit, which is 2, which actually means 20, so start one place to the left. Write a 0 or shift left. 2 times 5 equals 10. Write 0 in the tens column of the second partial product and carry 1 to the hundreds. 2 times 4 equals 8, plus carry 1, 8 plus 1 equals 9, write 9 in the hundreds column. 2 times 2 equals 4, write 4 in the thousands column. So the second partial product, 245 times 20, is 4900. You can write it as 4900 with a 0 under the 735 to show the shift. Finally, add the two partial products. You will get 5635 as the answer. Try this example and make sure you get the correct answer, which is 63648. Even with larger numbers, the process remains the same. Multiply each digit and add results carefully. An area model helps visualize multiplication. Each box shows a partial product that adds to the total. Division finds how many times a number fits into another. Here, 12 fits into 816 exactly 68 times. Let's divide 816 by 12 using long division. We'll follow the steps: divide, multiply, subtract, bring down. Set up the problem. Write 816 under the division bar and 12 as the divisor on the left. Look at the first group of digits. Since 12 is a two-digit number, we check the first two digits of the dividend, 81, because 12 does not go into 8 alone. Divide. How many times does 12 go into 81 without passing it? We try 6, because 6 times 12 equals 72, and 7 times 12 equals 84 would be too big. So the first digit of the quotient is 6. Write 6 above the 1 of the 81, in the tens place of the quotient. Multiply. Multiply the divisor by that quotient digit. 6 times 12 equals 72. Write 72 under the 81. Subtract. Subtract. 81 minus 72 equals 9. Write the remainder 9. Bring down the next digit from the dividend, the 6 in 816. Now we have 96. Repeat the steps with 96. Divide. How many times does 12 go into 96? Try 8, because 8 times 12 equals 96 exactly. Multiply. 8 times 12 equals 96. Write 96 under the 96. Subtract. 96 minus 96 equals 0. There are no more digits to bring down and the remainder is 0. This means the division is exact. The quotient we wrote across the top is 6 then 8, so the answer is 68. Check. Multiply quotient times divisor. 68 times 12 equals 816. Since the product equals the original dividend, our answer is correct. Estimation tip. Before starting, it helps to estimate. 12 times 70 equals 840, which is slightly larger than 816, so the exact answer should be just under 70. That matches 68, so the result is reasonable. Common mistakes to watch for. Trying to divide with just the first digit, 8, instead of the first two digits, 81. Picking too large a digit, like 7 times 12 equals 84 greater than 81. Forgetting to bring down the next digit. That completes 816 divided by 12 equals 68. If there's a leftover after dividing evenly, that's the remainder. You can write it as r followed by the leftover. Set up the problem. 97 under the division bar and 8 as the divisor. Start with the leftmost digits. 8 goes into 9 once, because 1 times 8 equals 8, and 2 times 8 equals 16 would be too big for 9. So write 1 in the tens place of the quotient. Multiply. 1 times 8 equals 8. Write 8 under the 9. Subtract. 9 minus 8 equals 1. The remainder after this step is 1. Bring down the next digit, the 7, making 17. Divide 17 by 8. How many times does 8 go into 17? 2 times, because 2 times 8 equals 16 and 3 times 8 equals 24 would be too big. Write 2 next in the quotient, so far quotient is 12. Multiply. 2 times 8 equals 16. Write 16 under 17. Subtract. 17 minus 16 equals 1. Now there are no more digits to bring down, and we have a final remainder of 1. Answer format. We write the quotient as 12r1. Read, 12 remainder 1. Check. Multiply quotient times divisor and add remainder. 12 times 8 equals 96, plus remainder 1 gives 97, the original dividend. So the answer is correct. Estimation tip. Estimate. 8 times 10 equals 80, and 8 times 12 equals 96, which is just under 97, so the quotient will be 12 with a small remainder. That matches what we found. Common mistakes to watch for. Forgetting to bring down the 7 after subtracting. Using the wrong multiplication, e.g., writing 3 instead of 2 when dividing 17 by 8. Not writing the remainder when it exists. This diagram helps learners follow the 4 division steps: divide, multiply, subtract, and bring down, until no digits remain. Next part is estimation. Estimation helps predict or check results before doing exact calculations. It's useful when an approximate answer is enough. Round each number to the nearest thousand or hundred, then perform the operation. This gives a quick, reasonable estimate. 4356 plus 1782. When we approximate it, it will give us 4000 plus 2000, then we get the total of 6000. In this case we will have an idea of around what value the answer would be. The same in the second one. When estimating multiplication, round both numbers to nearby easy values, then multiply mentally. Rounding the divisor and dividend makes division simpler to approximate. This shows how close estimates are to actual answers, proving that estimation helps check accuracy. Let's practice estimating sums, differences, products, and quotients. Try rounding first, then calculate mentally. The answers you should get are 1. Around 7,000, 2. Around 3,000, 3. Around 6,000, 4. Around 9. Today, we covered how whole numbers work, from place values to complex operations. Understanding these basics makes all higher math topics easier. Place value shows each digit's importance. Numbers can be read, written, compared, and rounded. Mastering operations builds problem-solving skills. Estimation checks if answers make sense. Well done. Understanding whole numbers helps you in everyday life, counting, budgeting, or measuring. Keep practicing and have fun with math.